Hello everyone, today we'll be solving the question the vowel matrix which came in starters 94 happened on 14th June 2023. Let's start with the problem statement. Neo finds himself in a high stakes situation. He has a string S of length n and his task is to crack the string n using the vowel matrix. The vowel matrix is a unique cryptographic scheme where the string is sliced into multiple pieces such that each piece contains exactly K vowels. Determine the number of ways you can slice the string S using vowel matrix scheme. Since the number can be huge, print it modulo 10 to the power 9 plus 7. The vowels to be considered are A, E, I, O, and U. And it is guaranteed that S contains at least one vowel and the number of vowels in S is a multiple of K. Okay, so let's see the problem statement in a different way. The test case that is given to us is 3, 1 and the string is new. Let's work through a brute force approach to find the output that is given in the question. What we need to do is to slice this string into a into n or k or any number of groups such that each group contains exactly one or k vowels. This string has two vowels at index 1 and at index 2. Can we slice this string at index 0 here? No, because this will leave us with a group having 0 and 2 vowels, right? Can we slice it from here? Yes, it is a valid slicing as this has one vowel and this has one vowel. And since there are no more options, our answer is 1. Is it correct? Let us see. And yes, it is correct. Let us take another self-made test case. Let us take my name and it is spelled as C H A N D A N. As we can see, it has two vowels at index 2 and 5. So let's traverse. Can we slice it from here? No, obviously not. Two vowels, zero vowel, invalid. This, no, still no. Here, yes, it is possible. We can slice it as this substring has one vowel and this substring has one vowel as well. Here, yes, it is also true. Here, yes, it is also true. What we observe is that we can't slice after we have started the last group of K vowels, right? We can't slice it from here or here, right? Neither we can slice it from before the last vowel of the first group of K vowels, right? That is A. We can't slice it from here, right? Neither from here. So what we deduced are these 2 points. Please keep these 2 points in mind. These will come in handy when we will be coding, right? So, 2 or 3 points that I would like your attention on is that our answer is 3 in this case, right? Yes, as we can slice it from here, here, and here. It is equal to the number of consonant between any two groups of K vowels, right? That number of consonants plus 1. There are two consonants between these two groups. Now the first K group ends here and the next group starts here. The number of consonants between them are 2 and our answer is 3. That is 2 plus 1. So what if there are more than two groups of vowels? Let's explore that as well. If let's say, get rid of this. Okay. Why are you not working? Uh, yes, yes. So yeah, let's add another DN for the sake of having one more group of K vowels, and the another group of K vowels starts here. This is the first group. This constitutes the second group. It's the starting and ending as K is one, and this constitute the third group. Right? These groups can't be sliced. We can't put a slash between these groups. We are agreed on that platform, right? The answer that we have to find is given by these consonants that are left between the groups of vowels. And for if we only had a string up to here, our answer would be 3, right? 1, 2, 3, n plus 1, number of consonants plus 1. But if we have more than one such sub problems, we need to multiply the answer to that sub problem. Why? Because if we put a slash here or slice the string from here, every slash is possible, right? It is not dependent on this. If we put a slash here and here, this is also a valid slicing here and here, again a valid slicing here and here, again a valid slicing, and that goes for here and here as well. Hence, the answer for number of valid slicing of this string should be 9, right? That is 2 plus 1, 3, multiplied with 2 plus 1, 3. This is the process or algorithm that we have deduced until now using these two test cases. And to test that we are standing on the right grounds, we would also work it on the another given test case that I suppose is 10 and 2. Uh, to our benefit, k is not 1 here, and this gives a wider range of perspective to us. And moreover, this is the kind of approach I always take while solving questions during the contest. Always make your test case to test your algorithm and then verify it using the given test case. Never base your code on the given test cases as they can be misleading, right? And let me just check that I have copied it correctly. Babylonian, okay. Baby. mm, So, yeah, we have our string. Let us find our vowels. And we got our first vowel at index 1, our next vowel at 5, then at 7, and then at 8. So, the first group should be this, right? Because if you remember the 2 points that I told you, we can't put slices before this and among these. So this is one group, and this would constitute the next group, right? I hope that it is clear until now. And we have one consonant between these two groups, and hence our answer should be yes, 2, 1 plus 1. I hope that you have grasped the idea between finding the answers, and I pretty sure that you will be able to code it yourself, but For the sake of it, let's look into the code ourselves. Okay, so here I have taken m as 10 to the power 9 plus 7, and here I have taken the input of the test cases. Moreover, this is the length of the string that is given to us and the number of vowels in each substring. Moreover, we have taken the input s, and here I have taken a vector v to take the input of the indexes where the vowels are present, right? A, E, I, O, U, and I am putting the index inside vector v. And this if statement is not important. While coding this, I didn't pay attention that the number of vowels present in S is a multiple of k, so you can skip this. And I start from k is equals to 1, as this would ensure that the first k vowels are being covered. I always increment I with k, as we need to move every further groups of k vowels. Moreover, first I check that if I plus 1 is within the bounds of v, and then as always I calculate here the number of consonant between two groups of vowels in this manner. If I had written it as this, it would be more understandable, as this is the number of elements between the first vowel of the next group and the last vowel of the previous group, right? For example, if we take this, then 7 minus 5 is 2, minus 1 is 1. That is the number of consonant between those two groups. And the plus 1 is our formula. Okay, there is a bit of mistake. That should be minus 1 and plus 1. This gives the number of consonants, and the plus 1 is due to the formula. We can skip it as it's not that important. And as you know, that answer can go out of bounds, and we are taking the modulus of 10 to the power 9 plus 7 and printing the answer. Let's check if our answer passes all the test cases. I suppose that the site is not working right now, and the solution will truly work. If there is any problem, you can always reach me out on in the comment section. I hope that I was able to convey my solution to you in a proper manner and you were able to understand that. Thank you.